Come.
Thank you. That's always is a pleasure to be in this deep tech atelier, because that's one thing where innovation meets science, and I think that's very essential in this field. I think I will give you a kind of helicopter overview about what is happening in photonics and smart materials in this ecosystem in Latvia. And let's start with what I think are the flagship here. If you look on the way how people treat companies, they say what is the growth and relevant numbers. I would say that from productivity perspective and from growth perspective, the fiber optics is the winner in the Latvia. We can call on a global scale that Latvia is a fiber optics country. So one of the players in this field is LightGuide, which produces very nice systems from fiber. This is not telecommunication fiber. This is specialty fiber for medicine, for technical applications, research applications, measurements, instrumentation, whatever. So including capillaries for far infrared. We have not only one company, we have even two companies. So the second company is Ceramoptek. It is a German company, but only fab in the world they have here in Latvia, in Livāni. So they do very similar things, but of course there are some differences between these two. But if you look on the figures, they both grow at the pace which is very high, which are double digits per year. Some years it was even above the 20%. So somebody says about the monitoring systems, radiation monitoring systems, detectors, and this is about Baltic Scientific Instruments. The story is very simple. So if they start the town of Singapore search for a best in the world radiation monitoring system in the air and oceans. They came back to Baltic Scientific Instruments to install this system. That's it. So you heard here about virtual reality, augmented reality. The Euro LCDs is one of the liquid crystal fabs in Latvia, which in Europe is located here in Latvia in Ventspils. So light space technologies, you saw the nice presentation. So this is how the concept comes to the reality in the first prototype. This is how it looks. Grow glass. Grow glass is a world leader in invisible glass productions where you have 2 to 3 meter size. So nobody else can compete on this market. World leader, of course. Many of us use infrared optics. Not all know that most of this optics is produced in Riga, actually. It's light path technologies, which somebody remember as ISP optics. Sidraba is doing coating machines, as well as this mega coating machine for a grow glass. So they do also lithium deposition, which is very fashionable now, because we are moving from lithium-ion batteries to lithium metal batteries. Here we are under the roof of commercialization reactor. I suggest you to visit their site and look on their portfolio, but I will give you some glimpses. There's a company, Eventech, which is a world leader in accurate measurements of time. So this is kind of picoseconds. So it's millisecond is 1,000. Nanosecond is 1 millionth. Picosecond is 1 trillionth of the second. This is a precision where you, from the space, you can have a laser location with a centimeter and sub-centimeter precisions. Now they are looking also on quantum technologies, and they created their own spin-off. Despite that's still a startup company which focuses on space industries. So there are people who are working also photonics again. Yeah, it's multispectral imaging used to detect the skin cancers. There are several groups actually doing this in Latvia. This is one For example, there's one which is working also, startup working on OLED materials. We know them well because they do it in our institute. Then there are people who are using terahertz or other antennas based on metamaterials. There are people who make a secret encoding of the materials using nanoparticles as a protective coding of anything. For example, they are including additive manufacturing, plastics, for example. There are people who already look on additive manufacturing of aluminium. So there are people who are also developing in this country the thermal metamaterials. So you see what is the landscape of these startups which are here, which might be next new industries. Also, this is one of the startups which also we know very well because they do research in our institute, which you see in this data. All these data are publicly available in internet, so it's or mine own photos. So they are working on lithium-ion battery electrode technologies. So there is another one, accelerator called Build It. I also suggest to look on their portfolio. There are some glimpses there. One of them is NACO Technologies, which is currently very focused on hydrogen. This is one amazing startup because they go for second exit. Their first exit was to Schaeffler about the coatings. This is about the hydrolyzers producing from water hydrogen. And amazing company, doing a lot of things. And currently they have get the financing to really build the device. Of course, there are people who also, this is also photonics, I would say. It's a Swiss Army knife for video lights. So you can, from these modules, you can produce any shape you want and need. And of course, there is a company which also is well known, Casprint, which prints you, in a certain cases, a treatment, special treatment for your broken arm or leg or whatever, which is ventilated, waterproof, and lightweight, and much better than your old gypsy environments. So what I'm also like that if you look on all these companies, what they need competencies. They all need competencies, and this is why I'm really proud to announce that finally our national government announced Innovation Fund for ecosystem competency development. And this is about, as written here, working together. So this is one thing which I see in every place, is that all the institutions having competencies should learn how to work together, not compete, but cooperate, and make each competence to become an excellence. Because if you duplicate, you dilute. If you focus, then you concentrate, and the synergy is much bigger. So this is very important thing, is let's see what happens. So after 2-3 years, we can discuss what is the outcome of this one. So, of course, a bit of, advertisement about our institute. We are, as you see, a strong national innovation ecosystem player. We are among the key, let's say, focus group, or how it's called, key core group of this photonics and smart materials ecosystem. Because we have a 44 years experience in this, we are about 300 people there, 325 to be precise. We have 125 PhDs in our institute. So this is a size. We have also a nanotechnology center there, which is very important for modern photonics. And we see that our specialty is a polymer photonics. And we believe that this is an alternative platform for the silicon photonics, lithium niobate photonics, indium phosphide photonics. There are many amazing things there. We also have our first licensing to Thorlabs for the world's fastest infrared light sensor. It's really world's fastest infrared light sensor. And we have our first spin-off in a completely different field, that's microfluidics. So you see here a gut on chip. So organ on chip doesn't mean that it replaces your gut, but it emulates your gut, because it's a 3D structure. This is how it looks. What we produce is a shell where these biologists grow these cells. So this looks like this small such size chip. So this is what I wanted to tell you, and I'll be glad to answer any questions. As I said, that's a helicopter view of our very vivid, mature, and startup community of photonics and smart materials. Thank you.